Hello everyone, welcome to my YouTube channel. Today I will be teaching you about what is an algorithm. Have you ever followed a recipe using Google Maps, arranged the books on a shelf, or searched something on the YouTube? If yes, then you already know the idea behind the term called as algorithm. Many people hear the word algorithm and immediately think about something difficult, mathematical, and only related to coding or programming. But at its core, an algorithm is actually a very simple idea. An algorithm is a clear set of step-by-step instructions used to solve a problem, complete a task. That is it. In plain words, it's just how one task should be completed. That is it. Let us understand with a very normal example of making a tea. See, suppose your goal is to make a cup of a tea. You need some input. Input could be water, tea leaves, milk, sugar, and a cup. Then you follow a process. You boil the water, add tea leaves, add milk, add sugar, let it cook, strain it, and pour it into the cup. Finally, you get the output, a cup of tea. So every algorithm has three basic parts. First is input, second is process, third is output. Input means what you start with, process means the steps you follow, output means the result you get. In computers, this idea is used in the same way. A computer takes some input, follows instructions, and gives an output. Let's take the example of Google Maps. When you open Google Maps and search for a route, let's say from this point to this one. The process is the set of steps Google Maps use to check roads, traffic, distance, and travel time. The output is the route it suggests. The important thing is an algorithm is not a magic. Whatever you can see is complete clear steps from going from this point to the end, this point. Let's understand step by step instructions by again looking at the tea example. See, the instruction is too broad. If I tell someone how to, I just tell a person that just make tea. So it's very broad topic, how, when, what. There are a lot of questions that needs to be answered. So for that person to understand, and if there is a term called as common sense and experience, but a computer doesn't have that much experience, or it just plains exactly what you ask them to do, right? Unlike a human. So instead of asking make a tea, we need to say take 1 cup, boil water, add leaves, add sugar, strain tea, and serve in a cup. Now the instructions are very clear. This is one of the most important properties of an algorithm. Every step needs to be clear. Algorithm also needs to be correct. Correctness means the algorithm should solve the problem as it is meant to be. If your tea making algorithm gives you salty tea instead of sweet tea, something is wrong. Maybe the input was wrong, or one step was wrong in the middle. In computer science, correctness is very important. If an algorithm is used in a banking app, a hospital system, a traffic signal, or an aircraft system, it cannot give random or wrong results. It must work properly. Now let us take another real world example by arranging books. In this slide you can see there are some books put in the shelf, right? We need to arrange it based on the chronological order in which they arrive in a dictionary. So let's suppose we have 10 books on the table and we want to arrange them alphabetically. Your input is the unordered set of books The process is the method you use to compare titles and place them in order. Your output is a neatly arranged shelf of books. One simple algorithm could be: pick one book, find where it belongs alphabetically, and place it there. Repeat this for every book until all the books are arranged. This is basically a sorting algorithm, which I will explain different types of sorting algorithm and how exactly they work in the subsequent videos. For more computer science related videos, follow this channel and press the bell icon. So, sorting is one of the most common tasks in a computer science. Your phone sorts contacts alphabetically, shopping website sorts products by price, music application sorts playlists by name, artist or date added. But there is something interesting. There can be more than one algorithm for the same problem. For arranging books, one person may pick books one by one and place them correctly. Another person may first divide books into groups from A to F, then G to M, then N to S, and then the last T to Z. Then sort each group individually. Both methods may reach the same output, but one may be faster depending on the number of books. This brings us to the efficiency. Efficiency means how well an algorithm uses time and resources. Just to put out in plain words, if you have only 5 books, almost any method will work quickly, but if you have 5,000 books, the method matters a lot. Slow method may take hours, but a better one can do the job in just minutes. The same thing happens in computers. If an application has to sort 10 items, speed may not matter much, but if Google has to search billions of web pages or a delivery app has to calculate routes of thousands of drivers, efficiency becomes extremely important. An efficient algorithm gives the correct answer faster and uses fewer resources. Now, coming back to the Google Maps example, when you ask for directions, there are different possible routes. One route may be short but full of traffic. One route may be the fastest. One route might have different traffic, as you can see in this slide. So, the algorithm has to consider these things. First is input, your current location, your destination, and in which terms that you want to do. Do you want to go from the shortest route or the fastest route, or the one which has traffic but other constraints are there, like you might be meeting someone in the middle. So, process in this case is comparable possible route, estimate time, remove bad options, and choose the best route based on the selected condition. Output is the recommended route. This is a very good example because it shows that algorithms are not about just one answer, but the algorithm output depends on the condition or the input which the user, in this case, in the Google Maps case, us have given. If the traffic changes, the input changes. When the input changes, the output can also change. This is why Google Maps may suggest one route in the morning, another route in the evening. Now, let us understand one more important idea. Algorithms must stop. An algorithm cannot run indefinitely. If it is running indefinitely without any reason, that would not be classified as an algorithm. Okay. A good algorithm should not run forever. It should eventually finish and produce an answer. For example, if you go back on the tea making process, we need to be clear on the stopping point, like boil tea for 2 minutes or boil until the color becomes dark enough. If that doesn't happen, tea might eventually we might run out of tea because the water has boiled and it has evaporated and gone into atmosphere. In computer science, this is important because a program stuck forever can freeze, crash, or waste resources. A good algorithm usually has these 3 qualities. In this particular slide, you can see the ingredients or the inputs are important. The process is important. The output is important. We take input, do something, get some output. This is all that the algorithm cares about. Okay. So let me just explain in clear terms that algorithm is not code. Algorithm comes before code. It's like building a house. The algorithm is like the plan or the blueprint. The code is like the actual construction using bricks, cements and tools. Without a clear plan, the final structure may be confusing. This is why programmers often think about algorithm before writing the code. You can see in this diagram, in the left side, first one is just plain steps in which we can write the codes. After this is a flow chart. This is called as a flow chart. The diagrams, I will explain flow chart as well in the subsequent videos. Please follow my channel to understand this in more depth, what a flow chart is and what these types of boxes or these figures mean. What is an end, what is start, what is this rhombus all about. Okay, so coming back, why should a beginner care about algorithms? Because algorithms are everywhere. YouTube recommends a video, an algorithm is involved. When Instagram decides what post to show first, an algorithm is involved. When a phone unlocks with face recognition, an algorithm is involved. When a food delivery app estimates delivery time, an algorithm is involved. When an online shopping application shows recommendation, an algorithm is involved. But remember, algorithms do not have human understandings by themselves. They follow exact steps and instructions, patterns and data that is being fed to them. That is why a good algorithm design is important. A badly designed algorithm can give wrong results, inappropriate answers, and that could lead to a very disrupted application performance. Okay. So here I have explained about algorithm. In the next lecture we will dive into some other topic